Welcome back to Maths with Mrs. J. I'm starting a new series of videos about functions and relations. The first thing you need to know is that this is aimed at students in Year 11 doing maths methods or the equivalent thereof in your particular state or country. By the time you reach Year 11, you are expected to have a basic knowledge of how to graph linear functions, so straight lines, parabolas, and some other basic functions using axes intercepts, perhaps using information about the basic shape of a function and how that function has been changed accordingly. A relation is really just a set of ordered pairs. That can be written literally as a set of ordered pairs like it is here, or it can be written in the form of an equation, or even an inequation, such as we have here. The domain is the set of the x values, or the first part of your ordered pair. So if we have just 4 points here, the domain would be -2, 0, 1, and 3. Your range is your set of y values, or the second part of your ordered pair. So it would be -1, 1, 2, 4. There are different ways that you can write your domain and range, and it depends a little bit on what your preferences are. Ideally, you want to write it in the simplest possible way. Quite often, the domain and range will both be R, the set of real numbers. In this case here, we've got a straight line. It works for all x values unless we're specified otherwise. So the domain is just the set of real numbers. The range is also the set of real numbers. There's nothing there that's precluded for any particular reason. There are no asymptotes, no holes in the graph, no problems there whatsoever. This one here is also actually the set of real numbers for the domain and range as well. A lot of people get a bit confused by inequalities. That's not something I'm about to teach in detail now, but just to let you know, if the line is, if you don't have an equals to included there, you're going to have a dotted line. If you have less than or equal to, you will have a solid line. And to work out which side to shade, a good way of doing that is picking a point. Quite often the origin is a good one to do, and say, does that satisfy the inequality? If it does, you shade on the side that that's on. If it doesn't, you obviously shade on the other side. So there's some simple examples. Let's continue on and have a look at some further examples. All right, this is getting a little bit more interesting here, but still within the realms of what you would be expected to know. Here is a circle, all right? Your basic formula of a circle with a centre at the origin is x squared plus y squared is r squared, where r is your radius. The domain of this, now let's think about this for a minute. The x values involved are only from -5 up to +5. My preferred way of writing that is like this. If you use your square brackets, that means those points are included. If you use a curved bracket, that means that point is not included. Your y, well, the range is going to be the same thing, from -5 up to 5 inclusive. You'll notice there are no x values outside, so less than -5 or greater than 5. No y values less than -5 or greater than 5. Another way of writing that would be, for example, your domain is x is a real number such that -5 less than or equal to x less than or equal to 5. You'll find a variety of different ways of writing the same thing. It doesn't really matter as long as you are specifying the correct domain and range. This one here, a lot of people get confused by. If we're saying x squared plus y squared is greater than or equal to 25, we're talking about the area outside the circle. Now, some people think that that means that you can't have x values between -5 and 5. You still can. Look here, your x value is about -3, isn't it? Any x value is valid here and any y value is valid here. If we had less than or equal to 25, it would be inside the circle and then it would be the same domain and range as we had there. All right, your garden variety parabola. All right, y equals x squared. It doesn't get much more basic with your quadratic functions than that. Your domain is just going to be the set of real numbers. Now your range here, let's think about this for a minute. The lowest possible value of y is at 0, isn't it? So there are a couple of ways we can write this. We could say r plus union with 0, which means all your positive real numbers and 0. We could say y is a real number such that y is greater than or equal to 0. Or we could say from 0 to infinity, but we can't include infinity because infinity is not a number. All right. You cannot put infinity on a number line, so it's not a number. It's not a real number. So there are three probably main ways that I would normally see that written for your range there. Domain and range here, we have a hyperbola. We have a vertical asymptote and a horizontal asymptote. I have done a video about graphing hyperbole. We'll notice here, if x is 3, the denominator would be 0, and not only that, but you have a situation where if you're approaching 3 from below, the curve is heading towards negative infinity. If you're approaching 3 from above, the curve is heading towards positive infinity. So that's an asymptote there. The domain, probably the easiest way to write this is all reals except for 3. It's probably the easiest way to do it. Same thing with your range. You can't have a y value of 2. So again, I'd do real numbers except for 2. That's probably the quickest and easiest way to do that. Okay, so how do we determine whether something is a function or just a relation? That's going to be the subject of our next video.